Imagine for a moment that we could reach out into space, scoop up a piece of the sun, and drop it here on Earth. What would actually happen? The short answer, nothing good. The long answer depends entirely on which part of the sun we bring down. The sun isn't solid like a rock, nor liquid like water, nor even gas like the air we breathe. It's plasma, superheated state of matter, where atoms are stripped of their electrons, forming a roiling ocean of nuclear fire. This plasma stretches across layers that get hotter, denser, and stranger the deeper you go, each the size of a house, and drop them on Earth. What we discover will make you glad the sun is 150 million kilometers away. Our first sample comes from the chromosphere, the thin outer atmosphere of the sun. It's not much, just a hazy. The chromosphere is extremely thin, over 1 million times less dense than Earth's air. If you brought it down to Earth, the sample would collapse instantly. Air would rush in to fill the vacuum, releasing energy equal to about 12 kilos of TNT. The result? A shockwave that could shatter windows, rupture eardrums, and even kill someone standing too close. Destructive, yes, but compared to what lies deeper inside the sun, this is little more than a warm-up. Now we move to the photosphere, the visible surface, glowing with the light that warms and sustains life on Earth. Here, the temperature is around 5,000 degrees Celsius. The surface is dotted with vast convection cells called granules, each one the size of a continent, churning endlessly as heat rises from below. If we bring a house-sized piece of this plasma to Earth, something different happens. Instead, it carries the energy of about 25 kilograms of TNT. When it arrives, it would blaze brighter than 1 million suns in the sky, even if only for a split second. The light would be so intense, it would ignite fires instantly throughout the lab. Curtains, paper, wood, everything would catch fire at once. What's left? A charred ruin, flames everywhere, but at least the destruction is contained to the lab. So far, our experiments have been messy, but survivable. But now, let's go deeper, where the real nightmare begins. Below the photosphere lies the radiative zone, a realm where plasma is so dense and packed that light itself becomes trapped. Photons released here can take hundreds of thousands of years to escape, bouncing endlessly from particle to particle in a chaotic maze. Temperatures climb to 2 million degrees Celsius. The pressure is crushing, holding the plasma tightly together. Now imagine removing a piece of this and dropping it on Earth. Without the sun's immense pressure to contain it, the plasma would expand violently, exploding with the energy of a thermonuclear weapon. The result wouldn't just level our lab, it would obliterate the city around it in an instant. Buildings, roads, and people would vanish in a blast brighter than anything Earth has ever seen. For kilometers in every direction, there would be nothing left but scorched ground and silence. This is no longer science, it's apocalypse. And yet, we've still saved the worst for last. Here, under unimaginable pressure, temperatures reach 15 million degrees Celsius. This is where hydrogen atoms smash together to form helium, releasing the energy that powers the sun. A house-sized sample from the core is beyond anything Earth has ever experienced. It contains the equivalent of 4,000 megatons of TNT. If such a piece arrived on Earth, the result would be apocalyptic. The plasma would expand instantly, unleashing an explosion so vast that it could destroy an entire region of the planet. Cities would vanish in a flash, forests would ignite, and oceans would boil at their shores. The shockwave would race around the globe, flattening buildings, rupturing eardrums, and shattering glass on other continents. Dust and debris launched into the atmosphere could block sunlight, plunging Earth into a mini ice age. Agriculture would collapse, ecosystems would crumble, and human civilization might never recover. The sun's core is so powerful that even a fragment, no bigger than a house, could end life as we know it. So, what happens if we bring it here? At best, we get a shockwave or a firestorm. At worst, we trigger a planet-wide catastrophe capable of erasing human civilization. The sun is our life source, but it's also unimaginably dangerous. We survive because it's far enough away. 150 million kilometers is the perfect distance. Any closer, and we'd burn. Any farther, and we'd freeze. The next time you look at the sun, remember this. Even the tiniest piece of it brought to Earth would spell disaster. Our planet can only thrive because of the delicate balance between Earth and its star. So admire it from afar. It's beautiful, it's powerful, and it's the very reason we exist. But never, ever try to bring it home.